All right, welcome everyone. Good afternoon. We are going to get started, and we're still admitting folks in, but it's my pleasure to kick us off with the third webinar in our series. I'm Christina Buck, Assistant Director with Butte County Department of Water and Resource Conservation, and this work is part of our Interbasin Coordination and Modeling Project, which Butte County is leading on behalf of the Wyandotte Creek and Vina subbasins. This work is funded through grants that those GSAs received through the Sustainable Groundwater Management Grant Program. And as I mentioned, this is the third in a series of 3 webinars that we've hosted. And those other webinars are recorded and posted on our website, along with technical memos that went along with that work. So we do have a third tech memo that's also coming that will document much of what you see today. And unlike with the others that were posted kind of a couple days ahead of time, that work is still being wrapped up, but we wanted to get this information out and kind of see what types of questions it generates as well. So that documentation will be coming. In some ways, this is the beginning of kind of a new story as GSAs and the subbasins begin to work on periodic evaluation work. So like the last 2 webinars, those 2 looked at the results of the evaluation of groundwater sustainability plans in subbasins along the Sacramento River. That was the first webinar. And along the Feather River, that was the second webinar. And so much like that, this is really just meant to be kind of informational and technical information that can provide a basis and is useful for each of our subbasins kind of in the region as we launch into periodic evaluation work. So it's not really the end of the story, it's the helping support some of that work that is just getting started across the region. So with that, I would love to introduce Lisa Porta, who will be giving this presentation, and also acknowledge the work of Sarah Roche and the team at Woodard and Curran, who did a lot of this work as well. We will do questions. We should have some time for questions and answers at the end, so jot them down or put them in the chat as we go along, but we'll go through the presentation first and then open it up for questions and answers. So with that, I will turn it over to you, Lisa. Thanks a lot.
Sounds good. Thank you very much, Christina. Thank you all for joining us today for, I think this will be the densest presentation we've presented on the series of 3 webinars. This is modeling, so it's a little bit more dense material, but hopefully it'll be useful and informational to you all. So today we'll have 3 major sections really. It's first we're going to kind of link it back to the interbasin coordination modeling approach and tasks and background of what was done before, and then outline the needs of current modeling and GSP implementation. Briefly provide a summary of updates to the Butte Basin groundwater model, and then go into more results and processing of a regional model from DWR to show what the results look like in our region here in Butte County. And then, end with some model collaboration and food for thought there for everyone present today on this, and then Q&A. So during the GSP development, and that ended in 2022, there was already a little bit of a need and identification of model coordination and collaboration in the region. And this was driven by the technical information outlined in the GSP regulations for interbasin agreements. As I mentioned in the other 2 webinars, no formal interbasin agreements were developed by the GSAs at the time, but this started the conversation on the figuring out estimates of groundwater flow across basin boundaries, estimates of stream aquifer interactions at boundaries. These are things that we know in the region we need to look at, because as I had described in the previous webinars, flow is connected between the basins and the subbasins in the Sacramento Valley. And so there's definitely, a need to understand those flows between boundaries a little bit better. So with that in mind, we had started looking at it during GSP development in order to come up with these 2 things, the boundary flows, so understanding how the water flows, the groundwater flows from one subbasin to the next. So you see the figure on the left here has arrows with the subbasins in the North Sac Valley. And so we were looking at how do the different subbasins and GSAs estimate the flow between the subbasins, and are we all in agreement at least in the direction of flow? And then the other big item was looking at flows, interactions between the stream and the aquifers at the major rivers. For example, the Sacramento River, the Feather River, those are oftentimes boundaries of our subbasins. And so understanding the flow, you know, the interaction of groundwater, surface water flow there and in between the subbasins is also really important. And so that is something that started back to our 5 pillars of interbasin coordination, the framework we had discussed during the first 2 webinars. During the GSP development, we had information sharing going on. And so we shared amongst the GSAs awareness of what tools were used in each subbasin. We looked at compilation of model characteristics to understand and look at differences and commonalities. But then the coordination kind of stopped there. We were not able to fully go into identifying and really connecting on flows between the subbasins. That was kind of beyond reach at that time. So we're kind of picking back up where we left off, but also this is going to be an ongoing effort over the next 20 years of GSP implementation to really work across the subbasins. And so here, I want to give you a couple slides here of an overview of what the modeling picture looks like in the North Sac Valley. So the figure on the right shows the different subbasins in the North Sac Valley, and the color coding represents which basins use the same model. So we have 6 different groundwater models that were used during the GSP development. Again, color coded by the 6 different colors here. So most subbasins use their own version of a model. Some subbasins, especially if they're in the same county, like the Butte County subbasins, the Tama County subbasins used the same model. Yuba County subbasins used the same model. But in essence, the good news is they all were based on the same numerical code, DWR's integrated water flow model. But there are some differences on inputs, on assumptions, they overlap boundaries. And so there's just some things that we were able to identify that were similar, but also the differences in approaches for the GSP development. And so the coordination there and the complexities and challenges for this modeling is that it's really tricky to consistently compare interbasin flows when you have such diversity of model types and boundaries overlapping and assumptions, because you're not really comparing apples to apples a lot of times. The other big challenge is that the key subbasin boundaries align with the Sacramento River, and it's also a model boundary in some cases. So the Sacramento River kind of splits our east and west subbasins here, and so that is a big hydrologic feature that makes it a little bit tricky to model or compare between the different models. And then we also have different vertical extents along the subbasin boundaries. So if we're trying to compare flows from one subbasin to the next, and if our models have different layering or depth of layers, that makes it mathematically, complicated to try to really compare flows between the basins. So those are some things that, were uncovered, and we are aware and working towards figuring out what's a better approach to coordinate on modeling approaches between the subbasins in this region. So fast forward now, that was then, and now 2022 and beyond. So now we're in GSP implementation. So now we're all working towards how we're using models and modeling efforts to implement our GSPs. And so currently, the big next item for Sigma is obviously the periodic evaluations. This is the 5-year check-in with the GSP implementation status and how we're doing. The periodic evaluations are due in January 2027, except for the US subbasins that already submitted theirs this year. But everyone else, the GSP periodic evaluations are due in January in 2027. And so the periodic evaluation modeling efforts will likely consist of 3 main items: is updating current and projected water budgets, simulating projects and management actions to assess long-term sustainability, and evaluating depletions of interconnected surface water. So therefore, this is why models are still a really important and useful tool for assessing where we are on the road to sustainability with Sigma. And as shown in my previous few slides here, if you look at these key items needed for the periodic evaluation, these items really could benefit from continued regional collaboration. It's similar to the other interbasin coordination and joint analysis efforts we described in the previous two webinars related to policy decisions. And so this is why today we wanted to focus on results and things that the basins are doing in order to move forward with the modeling efforts for the periodic evaluations. And so going forward, as of now or recently, we did a little bit of a poll to figure out what is this region doing. So we started with these 6 models, and it looks like we're still potentially moving forward with 6 models still and during GSP implementation. However, there's discussions, there are people talking to each other on figuring out connections between the models. So the status right now is that the Butte County models of subbasins, Butte, Vina, Wyandotte Creek, they will use the BBGM with revised conditions, boundary conditions, and a timeframe extension to 2024. And I will describe this a little bit more in the next few slides. And then in the US subbasin, the periodic evaluation was already submitted. They have a local also IWFM model that is updated annually, calibrated and maintained. So they move forward with their model. It's a long-term local model that I've used. So Butte and Yuba have their own local models. And then in the Tehama County subbasins, Corning subbasin is straddling the Tehama-Glenn County line. And so they had 2 models that were used during the GSP development, and the GSAs are currently discussing how to proceed. Sutter is going to update the model they used during the GSP, which was based on the C2V sim fine grid. And then Calusa had also a C2V sim fine grid model version. They're currently not looking at updating it. So this is kind of the status of where we are with modeling in the region. So moving into, because we're in Butte County and we're looking at what the work was done in the last few months. So as part of the interbasin coordination work, the grant funded from DWR, there was also an update to the Butte Basin groundwater model. So I'm going to refer to it as BBGM moving forward. This map shows in black the outline of the model. As you see, it overlies the 3 Butte County subbasins. It also extends a little bit into Los Molinos. It also covers North Yuba subbasin, extends into Sutter. And then the left boundary is the Sacramento River, and we'll talk more about that boundary. So how did we decide on how to update this model? Models, they're, as soon as you've published them, they're outdated. That's kind of what happens because it takes time to incorporate all the data and the information, and there's constant new information being developed. There's monitoring wells, DWR is doing some work, so there's constant information being developed that can be helpful to update these models. So we looked at all the new available data since the GSP submittal and triaged and looked at what makes the most sense to incorporate in the model. We then performed model calibration validation to make sure that it's still performing adequately. And then looking at computing the revised water budgets, extracting boundary flows, and then looking at making it useful for the periodic evaluation assessment. So that was kind of the workflow over the last year or so. And I wanted to just, and we're not going to go over every single word on these slides, but the presentation will be posted. So if you want to dig deeper into it, you can later. But basically, there was a lot of, like I mentioned, a lot of new information and data that was available. The challenge with modeling is some data may make a big impact or make a big change in the model. Some data may not. So some of the data we chose not to incorporate because there might be more work to process than really the effect will be on the model. Some information was maybe not quite ready for the modeling update yet, like the AM data. This is the aerial electric magnetic information that is with the helicopter that takes an MRI of the subsurface. So that information is further also refined by DWR, and they're looking at incorporating it in models as well. So we did not incorporate that in this model at this point, but we looked at a lot of other things: boundary flows, stream flows, extending the model through water year 2024 for the periodic evaluation, to have more recent updated water budgets, things like that. So after looking at all of this and understanding, bang for your buck, what makes the most sense to include in the model for the purpose of this modeling effort. This is what we ended up with. So those are the model revisions we completed. We feel this is now getting into a solid model for periodic evaluation purposes. The big thing was to modify the Sacramento River boundary condition. We modified it to be more in line with the latest C2V-SIM fine grid data and also water data library groundwater level data. So this is more now in line with what is regionally simulated and also with observed data. So this was a big change to this model. We also revised some of the hydraulic connectivity on the streams, again, to be more in line with C2V-SIM updates. We revised the ground surface elevation on the east side. There were some challenges with the inflows here in the Vina subbasin. We updated to the latest code available from DWR and also extended the time frame to water year 2024. So this is a more updated model, has more solid boundary conditions, and is kind of ready for prime time for for working on the periodic evaluation. So we call it BBGM 1.2. A tech memo will be developed or is being developed and will be posted. And this is the model that the GSAs are now going to use and refine for the periodic evaluations moving forward. So some challenges I mentioned a little bit before already is this model has the Sacramento River as the subbasin boundary. It's also the river boundary. It's the model boundary. So interbasin flows. It's a little challenging to compute accurately interbasin flows versus stream aquifer interactions here at this boundary. So that's one of the challenges with this model. Moving forward, uncertainties regarding regional modeling and data updates, trying to ensure continued consistency also with DWR updates to the model code. So it's the updates happen a lot and we can't always update this model to the latest code, but currently it's updated to one of the most recent ones. As I mentioned before, DWR is looking at completing some major revisions in the next year or two on their regional models. So that's another question. How does that connect back to this model? And then also coordinations with the GSAs and the subbasins that use different models. So we really identified, there's an identification of the need to coordinate regionally, work with DWR, get assistance to update the models so that they're more in line with regional understanding. So there's potentially a use to keep using both a regional, like a local model like the BBGM, and also connecting it to the regional model like C2V-SIM from the state. And this is things that are being kind of figured out now and discussed to see what's the most efficient way to update models into the future. So with all of that in mind, we decided for interbasin coordination purposes and to understand how the Butte County subbasins interact with their neighboring subbasins. We looked at the latest available C2V-SIM fine grid model from DWR that was released in June 2025. For those of you that don't know the acronym, C2V-SIM FG stands for California Central Valley Groundwater Surface Water Simulation Model Fine Grid. So this version 1.5 was just released, and we took a deeper look at the data here. Our colleagues from Wood and Kern did this work and looked at how the model flows behave between the subbasins in this latest edition from the DWR model. And I think the results are very interesting and good to look at. So briefly, this model covers the entire Central Valley, and in the purple circle there is where we are. So if you look at the BBGM is basically covering this area in purple, this model is big. It covers the entire Central Valley. So that gives you kind of a sense of scale. This model covers water years 1974 to 2021.
Fina GSA, this is Dylan.
And, oops.
Sorry.
No problem.
Fina GSA, this is Dylan.
I think we need to mute Dylan. Okay. So the model included some updates from the GSPs that were submitted by the GSA. So Butte counties provided some of their modeling input files, and so that information was included in this model. Other updates include land use, ET, some of other things, small watershed inflows, and some manual recalibration, but not a full recalibration of the model. So that's what DWR provided, and that's what we're using and the results I'm going to provide in the next few slides. And so one thing, though, to note is that with large models like the Central Valley-wide model from DWR, the resolution of the grid is much wider than the refined BBGM 1.2 model that you see on the left. So this is just something to consider mathematically. BBGM 1.2 has maybe some more accuracies and is able to have more accurate inputs and outputs because it's a finer grid than the larger grid from the statewide model. But you know, that's just kind of one of those comparisons that we're trying to make and understand here. So this is the BBGM model compared to the C2V sim here. In the report, DWR provided some comparisons to the Butte County GSP's annual report data, and we recreated those charts specifically for the Butte County subbasins. And so this is an interesting graph to look at. This shows in blue is surface water, in orange is groundwater. The dark blue is the surface water diversions that were reported in the annual report and the 2024 annual report, and then the corresponding estimate from the DW model. As you can see in the Butte subbasins, it's very, very close. So the C2V sim model really reflects well what the GSPs provide in annual reports. And then on the groundwater side, though, the C2V sim model tends to underestimate, especially in Butte, about half of the pumping. And then in Vina, it's also underestimating Salmon and Wyandotte Creek. So it's interesting to see, you know, even if you have the data put into the model, once you run the model, you know, there's processes that happen that, you know, translate into different outputs. So these are the kinds of things that would be helpful to keep working on to make sure that the statewide model represents sort of the local understanding too. But generally it is tracking though, it's pretty close. And it's really something that it's really great that DW are starting to be able to input some of the local data provided from the GSP implementation into their regional model. All right, we're going into a lot of graphics and results. Hopefully that all makes sense. So providing some groundwater budget highlights. And again, the theme here is the flows between the subbasins. So we're really highlighting today interbasin flows, stream aquifer interaction. I have more little graphics here for a reminder. So interbasin flows represent subsurface groundwater flow from adjacent zones within the model. And then stream aquifer is the vertical flow between the shallow groundwater and the streams. And so we're presenting results here as total annuals and annual averages over the model simulation timeframe and some sub timeframes as well. So here we go. We have these data pulled for each of the 3 Butte County subbasins. So starting with the Vina subbasin, the graph you're seeing here is net flows between the Vina subbasin and the neighboring subbasin. So the black line is the flow into or out of the Vina subbasin. So if the line is above 0, it means the net flow is into the Vina subbasin. Below the 0 line, the net flow is out of the Vina subbasin. So you can see most of the time the Vina subbasin receives flow from the neighboring subbasins. Sometimes it loses flow. So this is over the entire simulation timeframe. However, with most models, the most recent timeframe, we're more confident in the calibration and in the data inputs because we have more details on recent data collection. We have better data recently. And so we focused our attention also on the last 15 years, which is this red box here. And so the last 15 years show that Vina definitely has largely received flow, actually the whole time, from the neighboring subbasins. And so mostly from Los Molinos, and then it's, yes, from Los Molinos and then losing flows to Vina, to Butte subbasin. So this graph here shows the same data as in the time series, but this is showing the map from a annual average perspective. In blue, it's for the entire time frame, the simulation time frame between 74 and 21. And then in black, it's showing the last 15 years. So this now shows how the Vina subbasin interacts hydrologically with the neighboring subbasins based on this model. And so Los Molinos flow is into the Vina subbasin, same with Corning flow into the Vina subbasin, and then Vina loses flow to the Butte subbasin, and there's a tiny bit of an interaction here with the Wyandotte Creek subbasin. So on average, over the full simulation timeframe, Vina gains a net flow of 7,000 acre feet per year. But if you look at the last 15 years, the net gain is 19,000 acre feet per year. And so it shows that there has been changes in the overall hydrology over the last 15 years. It could be related to more accurate data, but it could also be related to the hydrology. We've had a couple of really big droughts, and so that could have an effect on that. And so this is the kind of information that is useful to think about when looking at interbasin coordination and model data. This is a regional model, so it's good. It's got all the flow within its own boundaries. If we were to look and compare this to the Butte subbasin, the Butte Basin groundwater model, this would probably look a little bit different, and we will have those ready for the tech memo. It's just we didn't have it ready for this presentation. So moving into the Butte subbasin, similar approach to the graphic. So above the zero line, it means Butte subbasin is gaining, below it's losing. Well, as you can see here, the black line, which represents the net flow in the Butte subbasin, is always below the zero line. So the Butte subbasin is over the long term losing water on the net perspective to its neighbors. And so if you focus on the red box here, the last 15 years, you can clearly see that there's a trend, but the trend is actually not going down. It's just the average is staying pretty stable from a perspective of interbasin flow. So it's also, if you think about hydrology, the Butte subbasin is on the path of the flow direction. We had showed some contour maps for groundwater levels in our last two webinars, and flow moves from the foothills down into the Sacramento River, and so the Butte subbasin is on the path of this flow. This is why you can also see the Vina subbasin losing water to the Butte subbasin, and then the Butte subbasin losing water again to the neighbors. So that's the consideration too, the regular regional flow of groundwater. So the Butte subbasin is losing water to its neighbors, to the three neighbors on each side. Here, the Colusa, Sutter, and Wyandotte Creek subbasins. It doesn't change all that much from a long-term perspective to the last 15 years. It just goes from 21 to 24,000 acre feet per year on average. So it shows kind of this basin is pretty stable as far as the flow, or subsurface flow between subbasins. So lastly, Wyandotte Creek, a much smaller basin, doesn't have the connection, is not as strong with it doesn't have as many neighbors. So it's mostly the Butte subbasin in orange. It's the main connection to the Wyandotte Creek subbasin. And you can see here there was a dip in the flow for the Wyandotte Creek subbasin, where it went from gaining to losing. And that is, you can see that connection back in the Butte subbasin. The Butte subbasin is usually giving water to the Wyandotte Creek subbasin, but during the 2015 and 16 drought, due to surface water delivery shortages, that was reversed temporarily. So you can see quickly how surface water use, or water use in generally in a basin, might reverse some trends in the groundwater flow as well. What happens on the surface does affect the subsurface. And so here the results for Wyandotte Creek on the mapping perspective, you have mostly gaining flow, and it changes slightly between the average long-term period from 9,000 acre feet per year to 6.5 thousand acre feet per year over the last 15 years. So definitely some changes, but not as big here as, for example, in Vina. So now we're moving into, and I'm going pretty fast, I realize, but I'm thinking that we can have some good discussions after, and I can always go back to slides that folks have questions on. So simulation of stream aquifer interaction, we are looking at the two main rivers in the Butte County subbasin, so the Sacramento River that's bordering Vina and Butte, and then the Feather River that's bordering Butte and Wyandotte Creek. And so we've broken up the two rivers into subsegments to be able to identify specific interactions between the different subbasins. And so again, like with the interbasin flow, this is computed over the entire simulation period and for the 15-year period, and also on an average annual basis. So you'll see similar graphs. So this is showing how we split up the streams. So in the model, all the little dots are basically a model node. So this is the node at which the flow is calculated at. And so then we just add all the flow at each node between the segments. So segment A is between Vina and Corning subbasins. Segment B is between Butte and Corning. C between Colusa and Butte subbasins at the Glenn County line. And then the D is between Colusa and Butte subbasin at the Colusa County line. And then, or actually this is kind of within the Colusa subbasin because, yeah, but it's kind of splitting it at the county line here. And in the Feather River, we have within the Wyandotte Creek, just this piece between Oroville and Thermalito Afterbay. And then we have FR2 is between Wyandotte Creek and Butte Subbasin. And then we have between North Yuba Subbasins because we're comparing this to the BBGM. So we have the North Yuba Subbasin compared to at the intersection with the Sutter Subbasin. So that's part of our Feather River corridor for those that attended the first two webinars, and then the Sacramento River corridor is the other side here. Okay, so again, this is net flows in the subbasin for the stream aquifer interaction. So between the border between Vina and Corning subbasins, the line shows the inflow of the river. So imagine here at that point where the river enters reach A, this is the flow of the river. And then this is compared to how the river is gaining within that entire reach A. And so really what this shows is that this reach has a long-term gaining with some decline since 2013. So you can see how the flows were kind of hovering around 40,000 acre feet a year, and now they're kind of closer down to like 20. So there's a little bit of changes in how the groundwater is gaining from surface water. So this is less gain. Sorry, the surface water is getting less from groundwater. So the river is less gaining, but it's still gaining generally overall. And so you can see that in the average, long-term average here. The gains went from 36,000 to 23,000 acre feet a year. Moving to the next segment. So reach B between Butte and Corning, it's a very small segment here. So there's not as much going on, but the flow is similar to before. So the Sacramento River is still has a lot of flow coming into it. And then this reach is mostly losing with not really a noticeable trend. There's a little bit of a more losing trend in the last 15 years, but not as big as for the other reach because it's smaller. And then between Butte and Colusa subbasin, same thing, Sac River inflow here over time, and then you have the gain. It's also a long-term gaining reach with some decline since 2013. You see a little bit of, since the last drought, things changed a bit. The hydrology in the Sac Valley changed a bit. So things are a little bit different. But generally speaking, we still have, the amount of flow of the inflow is, between 7 and 9 million acre feet a year. The 75,000 acre feet of change is really a drop in the bucket, right? It's the gain from groundwater is not a lot in comparison to the overall flow of the river itself. It's a big river. It's got a lot of flow. Reach D on the lower Sacramento River now is also gaining. Same story, has a little bit of declining trend since 2013, but yeah, so we're kind of in the same story here. Sacramento River is overall always a gaining river in this part of the valley for the model. So moving to the Feather River, looks a little bit different, different hydrology. It's not as big of a river. So we're looking at 3 to 2 million acre feet of inflow into the river. And here, the interaction with surface water and groundwater is a little bit, it's not as big. So this river is in this reach is gaining and losing over time, depending on drought years and wet years. So it's a little bit more reactive, but it has a lot less flow in it. So the interaction is kind of felt maybe faster, but it's not, the volumes are lesser. Reach 2 between Wyandotte Creek and Butte Subbasin. This one is always gaining over the long term. So that's all we kind of have to say here. It's actually not changed much in the last 15 years. It's kind of trending. It's always the same. So it's a very stable system here. And then same thing with the next piece, the North Yuba Sutter River. It's always gaining. Long-term average trend is not changing much at all. So stable as well. So the takeaway here is that this model can really help, understand on a big picture regional perspective, how are we doing with flows between subbasins, at the interaction with surface water and groundwater between the subbasins, and can really help with comparing this, connecting this to the local models developed and seeing how the understanding of hydrology between these different tools is the same or varies. So now I wanted to hope this was not too fast, but I can always come back. I wanted to just, hit the highlights here of this modeling output. But the last piece here was just to kind of tie this all back together and look at model collaboration in the region, efforts that have been undertaking, and maybe a food for thought on how this modeling can and keep being interactive in the region to better understand how these tools fare. So recent model collaboration efforts was two-pronged. Communications with DWR. So as part of this effort, we met with the DWR Sigma office folks on modeling just to better understand the updates being done to the C2V-SIM FG, the time frame for publication, and discuss general collaboration and coordination between state, regional, local actors to really be more in line on model updates and approach moving forward. The Butte County Board of Supervisors also sent a letter specifically on this topic to urge DWR to support GSAs for modeling efforts, especially as we move deeper into sustainability implementation and maybe having less available funds. The regional communication with GSAs, we organized a roundtable discussion with the modeling teams in the Northern Sac Valley. So the teams of these 6 models that we reviewed. So that was in January. That's some of the information I presented today came from that discussion to understand approaches between the subbasins, understand status of the model updates, and identify any ways that we can continue that collaboration, coordination regionally and also with DWR. So currently there's no real next steps identified on this coordination. All the subbasins are back deep in the weeds of doing their own modeling and developing their periodic evaluations, but this is good. This is just keep providing information and making sure everyone's aware of these tools and how they work. And so this is the last slide, food for thought. So long-term regional modeling coordination. On this map, I also overlaid the black outline of the BBGM, the Butte Basin model. So we do have the 6 models, and you can see how the different model boundaries can overlap with each other. Again, the situation, so makes the coordination or the comparison a bit tricky. So the challenge is that we have different modeling versions and overlapping boundaries. that is one of the reasons. It calls for regional coordination and collaboration with DWR, who's holding the large model updates, and each other looking at the more the local updates. So the goal is for this effort to continue supporting regional and sub-basin conversations by providing data and tools such as what we've provided today and will be available in a tech memo soon to inform decision-making by GSAs with regards to modeling and how to use these models. And also just considering, models on, none of the models are completely accurate or right. So there is a role for models and there's a role for data collection. So understanding the appropriate use and funding and availability of data versus modeling, and how data and models can inform each other, is also helpful for decision making as we move towards sustainability planning and implementation. So with that, I think I did enough talking for now. We'll see if we can get some questions, unless you wanted to add anything else, Christina, before we open it up to Q&A.
Yeah, that's great. Thanks, Lisa. I was gonna just follow up on one thing because I didn't mention it at the beginning, and that is there kind of as a next step, part of interbasin coordination along the Sacramento River corridor. We have pursued, Butte County, kind of on behalf of the Butte Sub-Basin GSAs, have pursued facilitation support services through the Department of Water Resources program to support interbasin coordination. And Tanya Carlone is the facilitator for that, and she's just getting kind of up and running to begin that work. And so there will be kind of future next steps along those lines. And like Lisa said, these 3 webinars and some of this information can feed into whatever that becomes and looks like in the future, and that's yet to be determined. So yeah, with that, thank you, Lisa. Great presentation, a lot of information. We do have time for questions, so you're welcome to drop your question in the chat, or you can click down on your menu. There's a react button, that's a heart, and if you click on that, then it kind of pops up with more options, and you can raise your hand and unmute and ask your question that way as well. So yeah, let us know if you have a question. I did get one. Oh, okay, here's one. Do maps reflect Ruddy Creek in the Wyandotte Creek subbasin?
I don't think it's simulated.
Yeah, I think I can.
Yeah.
That's a fairly small ephemeral creek, I believe, in Wyandotte Creek, and so it's not captured in kind of the regional model scale. I do have another question that came in through email. So the question is, how does this modeling relate to the shallow aquifer and the upper and lower Tuscan aquifer? Can you talk a little bit about that in terms of kind of hydrogeology, HCM, hydroconceptual models and modeling?
Yeah, so in order to develop these numerical models, and we didn't go into kind of modeling 101, but a hydrogeologic conceptual model with sort of the basic layering and the different aquifers is usually incorporated in it. And it includes aquifer properties that are supposed to be, representing the different types of layering and the different aquifers in there. So it's kind of included in there, I think, and by virtue of developing the model and then calibrating the values to observed values. So I don't know if that's enough of an explanation, Christina, or if you wanted to add to that.
Yeah, I think I would just add that it's kind of another, the vertical representation is another difference sometimes between localized models and the regional model. Right now, the regional C2B sim is 3 layers, right, Lisa?
Yes, I think
I
it's 4,
believe.
but the 4th layer is not active.
Okay. And Butte Basin groundwater model is 9, but same thing. It kind of has it's essentially 8 that are based on kind of different geologic layers and formations. So the answer is yes, but there's simplification that happens, because of these modeling tools.
Well, I believe so. DWR is working towards version 2, and that one will incorporate some more detailed hydrogeologic information from the AEM data. And so I think they're moving towards increasing the layers based on that data. So hopefully the next version will have additional layers, because that is important for water budgets and interbasin flows and being a little bit more refined in a subsurface flow estimation. You don't want to have too many layers, but there's a little bit of a, you know, an approach to that. A big regional model will have less layers because it's looking at a bigger picture, but in BBGM, it's more accurate or more refined to represent local conditions better. So the difference is there.
Yeah. All right, is there a place to view the data and analysis that you're conducting?
So this information will be, well, so first of all, there's C2VSIM 1.5 is published, and so there's a report on DWR's website. So they have all of the model files and input data, and then a tech memo that summarizes the changes made. So that's available. And then BBGM 1.2, we are developing a tech memo to show the changes we've made to the model. So that will be published on the Butte Basin, on the Butte County website. And then there's going to be also an interbasin coordination kind of informational memo that summarizes the gist of today's presentation into a memo that will be useful for, you know, as a companion to all the other interbasin coordination joint analysis and evaluation that we've done so far. So there's kind of 3 places to look at this information.
All right, any other questions out there? I know too, the Department of Water Resources, DWR, has been doing a really great job of integrating kind of the results of different analyses and work that they're doing into the Sigma data viewer, which is an interactive mapping tool, and it has lots of different categories that are relative to Sigma. So I'm not sure if the model results are in that tool or kind of online in that way, but I wouldn't be surprised if they head that direction in some way in the future. Those mapping tools have become more and more kind of comprehensive and useful. So we're appreciative of DWR in providing a lot of information that way. Any other questions? I think, oh, go ahead. Did someone want to?
Sorry, I didn't. This is
Oh,
Craig
good.
Officer from actually the Department of Water Resources. I just want to say first, thanks for inviting me to attend this. It's been really great to hear, you know, how locals are using our modeling tools, which we are developing, you know, for you all, and really encouraged to see, you know, continued collaboration and continued focus on collaboration. Just on that last point, we are. You know, as was mentioned, the report is available on our website. The model files are available on our website. Not the Sigma data viewer doesn't right now have any information related to like results of the model, but we are working on a separate web app to look at C2VSIM version 1.5 results in the web that, you know, sort of for non-modelers to take a look at the results. So don't have an exact release date on that, but we're hoping that we can release that soon.
Awesome. That's great news. Thanks, Craig. Yeah, I didn't want to call you out, but thank you for piping in. Yeah, and really appreciate Craig and his team and willingness to really have these conversations and think through, you know, how these different modeling tools kind of fit together or not, and you know what the different needs are at the local level and at the state level, and I think that would be, you know, one of my comments too would be our goal. We recognize, you know, as a county employee, right, and also, you know, involved through the County of Butte GSA, that there's a lot of work that the GSAs are doing and are responsible for, and depending on what subbasin, you know, there are some more pressing problems or things that are getting the attention of GSAs, whether it's recharge projects or demand reduction or just planning processes. And so, you know, the modeling is a useful tool, and Lisa talked through kind of some of the ways that it may be used going forward with periodic evaluations, but a lot of kind of the Sigma work and implementation of GSPs is and will move forward kind of without models. And so I think part of the thinking is how do we kind of save money and collaborate when we can by doing kind of what we do best in terms of locals being, you know, better understanding the details of land use and water sources and water use diversions from surface water, and getting that type of information into these integrated models that incorporate all of those different types of data sets, not just the groundwater system. But then, you know, as DWR really takes the lead on collecting basin characterization information through things like AEM and the helicopter project, and then figuring out how do we take that information and you know, refine the modeling tools that exist to incorporate that new information. We kind of at the local level, I think, want to step back, which is why we didn't include kind of that update, that type of update in the Butte Basin groundwater model, is to let some of that good work happen at the state level. And then if we can incorporate it kind of down the road, maybe it makes sense to do that. So really just trying to think strategically about using these modeling tools to help us understand the system better, to help us kind of think through monitoring needs. You know, where are the data gaps and how would our understanding improve with kind of on the ground real world data? And the modeling tools are just kind of a piece of the puzzle. So yeah, you can, there's a question in the chat about where you can send questions. I'll just respond with an email in the chat, but you can email us at bcwater@buttecounty.net. And we'll put you in the touch with the right contact. Any other questions or thoughts on this? All right, well, we can wrap it early. Hopefully you've enjoyed your lunch hour. And as Lisa said, the team will be wrapping up the technical memo that accompanies this work, and that should be out by the end of September or so. We will be posting these slides and a recording of this webinar. So if you know others that were interested but couldn't make it today, we will get that posted on our website. Probably a little bit more of a delay this time than the last two times around. So we'll send out an email when that is available, and it'll probably be sometime in about a week or so. And with that, a big thank you to Lisa again for your presentation and walking us through this really good content.
Thank you all for attending. Have a good rest of your week.
Thanks all.